Let's talk about square roots and cube roots. So a square root is a number that when multiplied by itself gives that number. So for example, 4 times 4 equals 16. So the square root of 16 is 4. What times itself got you 16? So you need to know the perfect squares below. They go from 1 all the way to 14, meaning that when I get 1 times 1, I get 1. 2 times 2 gives me 4. 3 times 3 gives me 9, and so forth. So these are all perfect squares, meaning there's a number multiplied by itself that gets us this answer. So if I ask you what the square root of 36 is, you're asking what number times itself gets me 36. So you remember back to your multiplication and doubles. So 6 times 6 gets me 36. So these are very important to know all the way up. You can do a little memorizing and memorize them all the way up. So now let's talk about parts of a radical. So when we use square roots, we use a radical symbol, or sometimes people refer to it as a root symbol. So this symbol is a radical sign or symbol, and then each piece of it we have different parts. So if there's a number in front of the symbol, that's called a coefficient of the radical. If there is a number right next to here, right in this area, it's an index. If there is no index sitting there, a clear as day number, then we know that it's a square root. We just assume it's a 2 there. If it's any other number there, then we go by what's there. So if we do cube roots, there'll be a 3 there, and so forth. The number that's underneath the radical symbol is a radicand. These can be a couple of different ways. We're going to start with very basic. And the whole thing itself is a radical. So we're going to do a couple examples. So I've put some stars by kind of their progression of difficulty. So we're going to start with A. So I want to know the square root of 100. So I'm asking myself, what times itself can get me 100? So this is a perfect square. So if I think about my multiplication facts, I know that 10 times 10 gets me 100. So the answer would be 10. Now, letter B has got a little star beside it. It means it's got to think a little bit more. Again, I want the square root, but inside now I have a fraction, 25 divided by 81. So I'm going to look at just 25 first. So I'm asking myself, what number times itself can get me to 25? So the square root of 25 would be what? So I know that 5 times 5 would get me 25. So the top number would be 5. And then I ask myself the same thing about 81. What times itself will get me 81? Well, again, I know my math facts, so 9 times 9 gets me 81, so the square root of 81 is 9. So the square root of 25 over 81 is actually 5/9. Now C and D have multiple stars, so pause the video and see if you can figure out what they are. Then come back and see if you got them right. Alright, so for C, this was a decimal. If you ignore the decimal place there and look at it, that's 144. So we know that 12 times 12 gets us 144. We put the decimal into play. It's the same thing as having 1.2 times 1.2. That would get us 1.44. And then with D, if you look at the number of zeros, there's 3 and 3 right here. So we knew we multiplied something that had 3 zeros times something else that had 3 zeros. It has to be the same. So 1,000 times 1,000 gets us our answer. Now, you need to know that the inverse operation of a square root or a radical, when we're doing a square root, no index here, we know it's a 2. To undo a square root, you have to square something. So for example, if I have 4 squared, 4 times 4 we know is 16. Well, if I have the square root of 16, I know that answer is 4. So they undo each other. And this will be helpful later. They're the inverse operations of each other. All right, let's move to cubes. So cube is a three-dimensional shape, object that have all equal sides. So length, width, and height, they're all equal. So cube, you've seen cubes before. And for a cube root, you still have the radical symbol, but now your index is a 3. So a cube root is when you have a number multiplied by itself, but 3 times that gives you a number. So for example, 3 times 3 times 3 is 27. So the cube root of 27 would be 3. So we're looking for what number times itself 3 times gets us that number. So let's do a couple examples. So the cube root of 64, we're looking for what number times itself 3 times will get us 64. So you may have to think a little bit. When they're smaller numbers, 64, don't start with really big numbers. So if I do 1 times 1 times 1, that's not getting me 64. 2 times 2 times 2, well, 2 times 2 is 4, and 2 more would be 8, so that's not quite it. 3 times 3 times 3, we already know that was 27 in our example. So 4 times 4 is 16, and then 16 times 4 will give me 64. So I know the cube root of 64 is 4. Now the next ones have some stars, so I want you to pause and see if you can figure these out, and then come back and check. All right, so B, you should have gotten 7. C, the answer is 8. And D, the answer is negative 16. Now be very careful with this. Cube roots can have negative square roots. So think about what we're doing here. If we want a negative number in here, we would say negative 16 times negative 16 times negative 16. That would still get us a negative answer. If we do this with a square root, it's a little bit different. So E is a big, what I call a Mac Daddy star. And notice that we're taking a square root. We're trying to find a number times itself that gets us a negative 49. Well, immediately you probably think, well, 7 times 7 is 49, but if I put a 7 and a 7, I'm not getting a negative 49. If I put a negative 7, that means the other one has to be negative 7, I'm still getting a positive 49. So this is actually a no solution, and there's a key thing you need to know. This is what we would call an imaginary number that you'll learn more about when you get into a higher level math. This is an imaginary number. We usually represent them with a letter I for imaginary. But cubes can have negative roots. But squares cannot. So that's very important to add to your notes. So put your little star there, circle it, highlight it. It's very important to know that situation. All right, let's move on to estimating square roots. So sometimes you don't have a perfect square or a perfect cube, and you need to figure out what it's close to. Now with a calculator, and I'll show you shortly how to use a calculator to do some functions, you can get a decimal. It'll round it close to you. But a lot of times these are irrational numbers, and we'll learn about irrational numbers soon. And we just want to find out what's close. So if I look at the square root of 26, I want to find the perfect squares that come right before and right after it. So this is where knowing your perfect squares comes into place. So if you go back to the beginning where we had the perfect squares listed, I know that 25 is a perfect square, and then right after 25 was 36. So then I can say, well, the square root of 26 is between the square root of 25 and the square root of 36. And then I know that the square root of 25 is 5, and I know that the perfect square of 36 is, or the square root is 6. So I look, I'm only 1 away this way. I'm 10 away this way. So I'm actually closer to this side than I am to 6. So this would be approximately a 5. Okay, we use approximately. It looks like a little kind of curved equal sign that tells us approximately 5. All right, let's do the same thing with B. All right, so we think about what is the perfect square before 7. Well, the perfect square before 7 would be 4, and the perfect square after would be 9, and the square root of 4 is 2, and the square root of 9 is 3. So I'm only 3 away from this one and 2 away from this one. So I'm actually closer to this side. So this would be approximately 3 would be my answer. Now, C is a little star. Notice that there's a negative out in front of the radical sign. So we have to think. 60 is not a perfect square. We know that from learning our perfect squares. So we got to find what's before and what's after. So the negative is going to apply outside of each of these because we're thinking about negative numbers. So I know before 60, I have 49. Doesn't look like a radical there. And after 60, the closest one would be 64. We got to put our negative there. So then the square root of 49 is 7. Then I apply that negative. So that's a negative 7. And the square root of 64 is 8. And then I apply that negative. So this answer for this negative square root of 60 lies somewhere in between negative 7 and negative 8. Now, with negative numbers, we have to be very careful. Think about a number line. We have a 0, then we have negative 1, negative 2, and so on. What comes first would actually be negative 7, then negative 8. So our point is going to lie somewhere in between here. So negative 8 actually corresponds with the negative square root of 64, and negative 7 corresponds with the negative square root of 49. Now, we are 11 away from the square root of 49, and we are only 4 away from here. So we're actually closer to the negative square root of 8, so we would actually reside somewhere in here. Okay, so our answer would be approximately negative 8. So those are a little bit different. You have to think about negative numbers and how they go backwards. It's not from smallest to largest, actually the other way around. So when you're going backwards, your small numbers are closer to 0, and as you get further away. So be careful with that. All right, so let's go to our calculator and look how we find the functions for square roots and cube roots on our calculator. We'll switch over to the camera here. I'll zoom in some so you can see. So again, we have a math button, and so we're going to be utilizing that. But first, if you look down the side, you'll see some items in blue that are kind of on the calculator. This button here, second, controls those. And if you'll notice down here, you have an x squared. That's when you want to square just a number, just any number you want to square. I don't use this button a whole lot. I use the little caret button to square something. So if I wanted to square something, say 8 squared, I can do it like that. Or I can do 8 and hit the x squared, and it puts the 2. Now the reason I use the caret is because then I can use it for anything, like 8 raised to the 3rd power, and I don't have to worry about doing something multiple times. Now if I want to undo something square, I want to find the square root, I'm going to use the square root symbol that actually corresponds with the x squared. Remember I said those were inverse. So I'm going to do second square root. It gives me the square root symbol. Then I can put in anything that I want. So if I wanted to figure out what the square root of 16 is, I just hit enter and it tells me. If I wasn't sure if it was a perfect square, like some of the ones we just worked with, I could do second square root symbol. Let's say the one we did was 26. I know it's not a perfect square. I know it's pretty close to 5. It's going to give me this, and it just continues to go on. So this is an irrational number because it keeps going, and we can see it's close to 5. So that's why we know it's not a perfect square. Now for cube roots, we have to use our math function. So we use our math, and if you'll scroll down, you can see a little 3 and then a 3 with a little radical sign. So the little 4th option there, if you click enter, it then now puts the radical sign with the number 3 index, and you can put then your problem in there. So if we wanted 64, we now have the answer is 4. So like the negative that we did, so I'll go to math, go down to the 4th option, and I'm going to do a negative using my negative sign, negative 4096, and when I hit enter, it gives me the answer of negative 16 that we saw. If I just did this with a square root, so let's say square root of negative 16, we know 16 is a perfect square, but there's a negative inside, and we can't have negative squares. We hit enter, it gives us an error. And notice it says non-real answer. That means it's not possible. That's an imaginary number. It's not that it's not possible, but it's not a real number, and we're dealing with real numbers. All right, so hopefully this helps. Use your resources, practice, and we'll see you soon.